Let's talk about artificial intelligence. It's often sold to us as this incredible tool that's going to solve the world's biggest problems, and that includes climate change. But then, in the very next breath, you hear about how much energy it eats up. So today, we're going to dig into that paradox, especially through the lens of India, and try to figure out how we can actually balance AI's carbon ledger. Let's jump in. And this is really the heart of the matter, isn't it? It feels like a total contradiction. On one side, AI is this amazing key to unlocking efficiency and optimization. But on the other, the very act of training and running these powerful models leaves behind a pretty big carbon footprint. So, how do you square that circle? Okay, before we even start talking about the amazing solutions, we have to get real about the problem. AI isn't some kind of magic cloud. It has a very physical, very real, and frankly, growing environmental cost. So where is all this energy going? Well, first, you've got these gigantic data centers. Think of them as just warehouses packed with servers running hot 24/7. Then there's the training. That's where powerful, energy-hungry GPUs grind away for weeks, sometimes months, just to build one AI model. And it doesn't stop there. Once it's running, every single time you ask it a question, that's called inference, it uses up more juice. All of it adds up, and it adds up fast. And this is where the problem gets especially sharp for a country like India. See, when your nation's power grid still relies heavily on fossil fuels, in India's case, a lot of coal, then every single kilowatt of electricity that a data center uses has a direct carbon cost. It's a straight line. So, in a way, more AI could literally mean more carbon emissions. But, and this is a huge but, this is where the whole story pivots. Because as big as AI's carbon footprint might be, it's actually dwarfed by a much, much bigger problem in India: good old-fashioned systemic inefficiency. And this is where AI's true power lies. Not just as a cool new technology, but as a master optimizer. The scale of the inefficiency we're talking about here is just immense. We're talking about cities choking on pollution, massive water stress across the country, agriculture that's super vulnerable, a power grid that literally leaks energy before it gets to your home, and cities that are just expanding at a crazy pace. Every single one of these is a massive, ongoing source of wasted resources and pollution. So here it is. This is the single most important idea to grasp. For a moment, just forget about the energy cost of AI and focus on this statement. All that wasted water, all that wasted energy, all those wasted resources, that systemic inefficiency is, you could argue, a far, far bigger polluter than all of India's data centers put together. And what's the one thing AI is perfectly designed to do? Fix inefficiency. And that brings us to the core concept of this whole explainer. It's this idea of a net positive solution. The question isn't whether AI consumes energy. We know it does. The real question is whether the energy and resources it saves are much, much greater than what it consumes to run. This slide just lays out the math perfectly. Think of it like a simple ledger. On one side, for every 1 unit of energy an AI system uses to, say, optimize a city's water supply, on the other side, it saves 10 units of energy that were being wasted by leaks and inefficient pumping. The result is simple, but it is so powerful: a net environmental gain. You've spent 1 unit to save 10, which means you're 9 units ahead. This is the powerful argument for deploying AI in a country like India. So let's see what this actually looks like in the real world. All right, first up, agriculture. This is a sector that's absolutely vital to India's economy, and it's also a huge consumer of resources like water. Just think about it for a second. Instead of just flooding fields, AI-powered sensors can tell a farmer, hey, this little patch of your field needs water, but the rest is fine. That ends massive over-irrigation. It can spot pests before they spread so you don't have to blanket the entire crop with pesticides. What's the bottom line? You get more food with less water and fewer chemicals. That's a direct win for the environment. Okay, next, let's look up at the sky. Air quality. It's a critical public health crisis in so many Indian cities. Right now, we mostly just react to bad air days. But with AI, we can actually predict them. By crunching data on weather, traffic, and industry, these models can forecast a pollution spike days in advance. And that means a city can do things like reroute traffic to avoid jams or ask certain factories to scale back for a day, preventing the worst of the pollution before it even happens. Water scarcity is another one of these massive challenges. India's water infrastructure is just vast, and a lot of it is old and leaky, which leads to an incredible amount of waste. So here, you can think of AI as a digital watchdog for the entire water system. It can analyze flow data to pinpoint tiny leaks in thousands of kilometers of pipes before they turn into huge breaks. It can help figure out the absolute best way to release water from reservoirs to serve farms and cities. And remember, better water efficiency means less energy spent pumping and treating water that never even gets used. And now for what might be the most direct application of all, the energy sector itself. This is where AI can literally help clean up the very power grid it depends on. A smart grid that's powered by AI can predict exactly how much power a city is going to need on a really hot afternoon. That stops power plants from firing up when they don't need to. It's also a total game changer for renewables like solar and wind because it can manage their unpredictable flow, making it way easier to plug them into the grid and rely less on fossil fuels. So, the potential is clearly massive, no doubt about it. But potential is not the same as a guarantee. To make sure AI really is a net positive for the environment, you need a plan. You need a blueprint for doing it responsibly. And here's what that plan looks like. First, prioritize efficiency. Don't just build the biggest, most power-hungry model. Build the smallest one that gets the job done. Second, power these things with renewable energy. That's a no-brainer. Third, and this is so important, be strategic. Apply AI where you'll get the biggest environmental bang for your buck, like in those water and energy systems we talked about. And finally, you have to set some smart rules. Discourage wasteful uses of AI and actively fund research into making the technology itself greener. You know, in the end, this quote just says it all. If we're not careful, AI can absolutely make the climate crisis worse. But if it's targeted, if it's efficient, and if it's applied with a clear purpose to tackle the biggest sources of inefficiency, it could be one of the most powerful tools India has for balancing its growth with sustainability. The goal isn't just more AI. The goal is much, much smarter AI.